Hey guys, and welcome back to an amazing new video which was requested so often by so many people of you that I now decided to make a video about that. And that topic will be custom authentication with Ktor, JWT and Android. So if you have some kind of backend that you'll also learn how to build here that has the JWT authentication mechanism, then I will also show you how you can properly manage that token and all that stuff in Android, because that's something you deal with very often in the actual professional Android world, you can say, because that's a very common authentication and authorization mechanism. So if you have absolutely no idea of how JWT authentication works or how authentication and authorization in general works, then this is the perfect video for you, because I will really go through all that from absolute scratch. You won't actually need to rely on Firebase anymore after that, on Firebase authentication, which is very popular among Android developers. I know that, but I really like this custom approach because it gives you so much flexibility when it comes to how users sign in, how you save your user data, all that stuff, which database you use, for example. We will use a MongoDB, which I will also show you in here, how you can set that up with Ktor. So I think we should just jump into the app that we will build here. It's a very simple and probably a little bit ugly app. You can see it tells us you're not authorized. Please log in. As I said, ugly app, doesn't matter how it looks like. It's really about the functionality, and you can make your own apps a lot more beautiful. I'm sure about that. First of all, the top two fields are for registration. So if we want to register as a new user, and the bottom two fields are then to log in. Let's actually try to log in with some invalid credentials first. For example, test user and test password. And if we then click sign in, it will load and it tells us an unknown error happened. I didn't do any fancy error handling here, so usually you should tell your users your username or password is incorrect. But it's all about the functionality here, as I said. Let's actually just create a user with these credentials now. So we say test user and test password. And if we click sign up, then it will also automatically sign in with these credentials if that sign up was successful. So we click that, and then it leads us to this kind of secret screen, which is only for authenticated users, which tells us we are authenticated and we can't go back here. And if we then actually close this and reopen this, then we will automatically log in because we saved the token. I will show you how you can implement that auto login feature. I will show you what happens if the token actually expires, because that can happen. Then we want to reload it and all that stuff. And if I just show you how you can build this Android app and how you can build a Ktor backend to implement this authentication mechanism, then this will probably not help you in any way to use this for your real user base, because all that stuff will happen locally. And you of course also want to know how you can deploy this backend, this Ktor backend, so you can actually use that with a real app, with a real user base. And that is something that I will also show you thanks to today's amazing sponsor, who is Hostinger, who also already sponsored an earlier video on this channel where we built a chat app with Ktor and deployed that on a Hostinger backend. So you can see they currently have a web hosting sale where you can get a website for like $2.99 a month, which is like nothing for a website. And you even get like encryption here. As you can see, you get a free domain, and even not just one website, you get 100 websites here. So it's totally worth it. The support is also very great. And we're actually not going to use this web hosting sale here. We will actually go to hosting and use the VPS hosting. VPS stands for Virtual Private Server, and it's basically nothing else than a remote Linux machine. So we'll then just later take our server that we'll build locally here in IntelliJ, our Ktor backend, and we package it into a single jar file, so an executable Java file, which we will push to this VPS Linux server here from Hostinger, and then we will run it there remotely so we can access it from anywhere on this planet. You will of course find the link to this down below in this video's description, where you will get to the website, hostinger.com. Here you then get different options for this VPS server plan. If you're just a developer and you want to play around, the VPS 1 is totally enough, or the VPS 2 one, as you can see, it's the most popular one. That is the one I will use for this video. And of course, if your user base grows, then more server resources of course makes sense, but that is a very individual factor. Once you're then decided for a plan, let's say this one, you will get to this page, and here you don't want to forget to actually add a discount code, because with the discount code Philipp 7, which you need to apply here. So if it wouldn't be applied, you would need to click on have a coupon code. You add Philipp 7, and then you can get up to 91% of all yearly hosting plans, which is great. So you can save a few bucks here, depending on which plan you actually choose. And just to show you how that would look like once you purchased one of the server options, this is the web panel of hosting, where you can just manage all your servers that you booked here. For example, you have the SSL, certificate activation, if you want to encrypt your traffic. For example, shared hosting, where I hosted one website here, and what we will use, VPS hosting, just a bunch of servers here on which you can deploy stuff. And then you could, for example, click on manage, and then you can see like the IP address, if it's running, you can see CPU usage, memory usage, disk usage, and all that interesting stuff, which I will get more into towards the end of this video when we'll actually get to the deployment part. And I think we can actually jump right into coding, and we actually won't jump into coding in Android Studio. Instead, we will simply first build our backend, because that of course makes much more sense if we actually have a backend to communicate with. And to create a Ktor project, we have different methods we can do this. On the one hand, if you have IntelliJ Ultimate, which is the IDE we will build this in, so we won't do this in Android Studio, then you can directly create a Ktor project inside of IntelliJ. There's like a project builder, some kind of plugin. However, if you don't have IntelliJ Ultimate, which I think most of you won't, then you can't directly do that in the IDE. That used to be possible, but not anymore. But we can, of course, still do this with this free website, where we can just build our own Ktor project here and configure that. It's start.ktor.io. You need to give it a name, of course. We're going to call this Ktor JWT Auth. Then we want to click on adjust project settings. Here we need to choose a build system, which we will leave at Gradle Kotlin. So the Kotlin DSL version of Gradle. Here your package name. I will choose PL Coding. And let's actually, I'll better make sure, I don't know if dashes are an issue here. I don't think so. We will use the latest Ktor version 2.0.1. We will use Netty as the engine. That's basically just what drives Ktor, what processes all the network traffic, just what it's based on. And we can choose different ones here, but let's just choose Netty. And we want to choose configuration in Hocon file. What's the difference, Hocon file or code? Well, if you choose code, then you configure your server directly in Kotlin. And if you choose Hocon file, that is some kind of JSON format, not exactly JSON, but very similar. And we will store our server configuration, like for example, forward tokens, and which port it's running on and all that stuff inside of that file. I like to have that in a separate file. We want to make sure that we add sample code, because then it will automatically generate quite some helpful code files already. And we want to click add plugins, because that's how Ktor is actually, that's how Ktor works. We can simply add plugins for every kind of feature we want to use. For example, for authentication. We want to click add here, because we want to use the authentication feature, and we want to use authentication with JWT tokens. So if you want to use other authentication mechanisms, you need to add these features here accordingly. And don't worry, if you don't add these here, you can always add these later by simply adding a dependency. So what else do we need? It automatically added routing here for us, which is used to respond at specific URLs, which we of course need. Then what else do we want? We want content negotiation. That is, so we have JSON support, so we can respond with JSON data for our app to understand. Call logging is something I usually put into that just logs every single request a client makes. And we want to use Kotlin X serialization. So that will be the library we will use to actually serialize our responses to JSON. And I think that's it. You can see there are also WebSockets, which I have a course about on my website, but we will actually just use these. And we can then click Generate Project. However, that's just to show you how you would create a new Ktor project. I actually would like you to get the initial source code for this Ktor project from my website. I didn't change any code there, just added some dependencies that we will use because I don't think I need to show that on video. So you will find the GitHub link down below in this video's description. You can simply clone it there and then open it in IntelliJ. Or if you don't want to do that, then you take this project you just downloaded and add the dependencies that I have. So once that's done, I will see you back in IntelliJ. All right, back in IntelliJ, that is how it will look like here. So you will have a build.gradle KTS file, which you will know from Android. It's just the Kotlin version of Gradle. Looks very similar. And you have a Gradle properties file, which is relevant for us now because the Gradle properties file contains the versions for our different dependencies. Actually, we won't use Coin here, even though I included this. Coin is a library for dependency injection which works with Ktor. However, it seems like currently it's broken with the latest Ktor version, which is this one. I am assuming they will soon fix that. However, right now it does not work, at least without any ugly workarounds, according to some GitHub issues. So that's why I won't use Coin here for dependency injection, and we will just do manual dependency injection, which is totally fine since that's not going to be a really big project. However, these two libraries are much more important and interesting for us. On the one hand, KMongo, which the name already suggests, is the Kotlin version of MongoDB, or the Kotlin database implementation. That's how we can use MongoDB in Ktor in any Kotlin project. And then we have Commons Codec version. What the heck is that? That is a very helpful library that just comes with a set of really helpful security-based functions, and we will use this here to hash our passwords. So I will even show you all the security best practices when it comes to authentication. So we will hash the passwords, we don't save them in plain text in our database, we will use salts, and what all that stuff is I will get to when we implement this. And then here in our build.gradle KTS file, we just have all these different dependencies here. So feel free to remove Coin, you don't need this. We can also remove this here and up here. And then we can click this little synchronize button in the top right corner. So we make Gradle sync, and then let's actually explore the package structure of our empty Ktor project. We have a main package here in source, then Kotlin, and then we have a plugins package. And it's actually not empty because those plugins that we added on the website are now already included here in this plugins package. So Ktor has some initial setup for these so that we don't need to do this. So for example, monitoring will configure our call logging feature so that we have proper logs. For some reason, it doesn't input that. Let's press Alt plus Enter and do that ourselves. Go to routing, and routing will simply add a very simple route here. So just the root one where it would respond if we make a GET request to that route with hello world. Let's just remove this. We don't want this initial route. We then want to go to security, which configures our JWT stuff. So we have an authentication block here, then we configure JWT, and we get some errors here, which we'll actually deal with later. We don't need to fix that now because we will change this configuration here a little bit anyways. And what all that means is, I will explain that of course. And we have serialization, which is content negotiation. So here we install the JSON feature, which gives us access to actually automatically parse our responses to JSON. We will make sure to also import content negotiation, and we want to make sure that we don't have this extra routing block here, because that would lead to an issue since we can only have one of these, I think. So we remove this. And then we finally have this application KT file in which we, on the one hand, have our main function, which gets called once we launch our program. And then we have this main module, you can say, in which we configure our server. So here we just call all these extension functions Ktor created for us. And just to make sure, I actually want to try out if the server properly runs. And for that, we actually have to get rid of these errors. Let's just fix this error here by saying environment is equal to this at configure security.environment. And then it will work, because we do have access to our environment variables here because we extend application, but here it didn't know from which of these different types, like from this authentication config, this JWT authentication provider, from where it should get that environment. So we need to explicitly state it comes from our configure security function from this application. Let's launch our app by going to application and clicking this little play symbol next to main and run. And then you will see down here in your console that your server is running, and it actually crashes because this address is already in use. That's cool to show you at least, because I already have the server running that I prepared here for this video, and it's running at the same port. You can see our port is 8080, which is kind of the standard port to test this. We can change this. So if this happens to you, we can go to resources, our resource package, and here we have our application config. I want to open that, and here we have our port, for which we could now choose anything basically. For example, 8001. If we then relaunch this, then it should not crash because this address with this port is not in use already. However, I much rather like to have the default port, which is why I just stopped my other server. I relaunched this with 8080, and then it should work just fine. You can also see here is a little bit of default JWT config, which we will get to when we implement this. So we can just leave that unchanged. Before we actually start with coding here, we want to actually create an account on Mongo Atlas. What is Mongo Atlas? Let's take a look here on mongodb.com/atlas/database. You will find all these links in the description, of course. Mongo Atlas is kind of, Firebase database, just MongoDB, and you have much more control over this. So it's a remote DB. That's what I'm trying to say here. This does not run locally on your machine here. This does not run locally on the server we will later use to deploy this. No, our server will actually communicate with this remote DB, which has the advantage that they manage everything for you. So you have very great analytics there, how much your database is actually used currently, how much free memory you have, and that would be quite a lot of work to set that up on your very own server. So we will just use this, and we want to click try for free. So for development purposes, this is totally free, and create a new account, which I will do here, and then I will see you back once I create that account and show you how you can now set up your database. Now, after successfully creating an account and verifying my email, this is how it will look like for you if you log in for the first time. So we want to click build a database, of course, because that's what we want to do. Here we will get our different options. Of course, they also want to earn money, but we don't want to give them our money, at least now, if we want to just develop something. So we use the shared plan, which is free, as you can see. We click create. Don't need any credit card for that. And here we need to set up how our database is actually hosted on what kind of server, which doesn't matter too much what you choose here. I'll just leave it at AWS, so that's what they use behind the scenes. And regarding the location, you should choose something that is close to where your users are, because then that's, of course, faster traffic. I will choose Frankfurt here. Then what do we have here? A cluster tier, which we will leave at that. Additional settings, we will leave cluster name. I'll just also leave that at cluster 0. That's basically something that summarizes some databases. So we click create cluster. Then it tells us how would you like to authenticate your connection. So we can either use a username and password, or we can use a certificate here. So that's just how we can log into our database, how our Ktor server then knows how to access this. So that's another advantage of Mongo Atlas. So you don't need to set that up on your own. I will just choose something here, and the password. You can even see this because I'll just delete everything here after making this video. So we can just use, I don't know, Ktor Auth tutorial. Let's choose that as a password because I will show you that anyways later in our Ktor server. Let's click create user, and I will copy the password before, and then it was successful, as you can see. So the next thing is, you can see in the bottom left, it tells us the cluster is provisioning, and this process will take 3 to 5 minutes. So now Mongo Atlas will actually create that new cluster and database for you. Actually not a database yet, but the cluster in which we can create the database. So I will see you back once that 3 to 5 minutes is actually over. So now that we have a user that can access our database, we want to create the database, of course. So we click on under deployment on database. And you can see that is our cluster in which we can create that database. We want to click on that. And what do we do now? We want to click on connect here on this little button. And then we see this here. Here we now have that little security wizard. So we can add an IP address that is allowed to actually access that database. So ideally we choose an IP address, which is ours, of course, otherwise that won't work. And later on, when we deploy our server, then we also need to add the IP address of our server we deployed the backend to, of course. You could also, if you want to have it very easily, you allow access from anywhere, which would then allow any IP address to access your database if they have your username and password. But this is just another layer of security, you can say. So I will click add your current IP address, add IP address, and there we go, that's it. Then we click on choose a connection method, and we want to click connect your application. That is now the connection string that we will use. What is the connection string? Well, that's just a string that contains all the information an app needs to access this specific database. So in our case, our app is our Ktor backend, and we can simply copy this, and all we need to do is we need to replace this password here with our actual password that we just chose here under database access. However, that is now good. That is our project here. We want to go to application, and here in our application module, let's just create a very simple instance using kmongo for this database so we can actually access our remote database. So val_db is equal to kmongo, and make sure to import this one from reactive streams, not this one. That's a common mistake I do. Dot create client, this one, and that gives us the option to pass this connection string. So we will say connection string is equal to what we just copied. So what do we want to do here is we want to replace this my first database with an expressive name, because as soon as we connect the first time to this, it will create this database with this name. We want to choose, for example, Ktor Auth. Then we also want to replace the password, but we don't want to put this as a plain text password in our code here. Instead, we want to use something called an environment variable. Those are variables that we can easily provide from the outside to our app, which the app can then use to find specific secret values. And what we will do is we'll simply say val mongo password is equal to system get_env, so get environment variable, and the name of that will be mongo password. And we can use this here to simply, make sure to replace this with our Mongo password. Then, of course, right now we haven't specified this password anywhere. How do we mention these environment variables, at least here for testing? Well, we want to go to this application KT field here. I want to click edit configuration. So we can add these environment variables here under the run configuration, and we will choose the password we chose on the Mongo Atlas website, which was, I think, Ktor Auth tutorial. And we of course need to name it so it knows which one we actually want to assign. That is mongo_password, and that is equal to our password. We click OK, and we're not done yet here with this create client. We also want to say a .coroutine, which gives us a coroutine client, so we can use MongoDB with coroutines, which of course we want since we love Kotlin and coroutines. And then we want to say get database, and here we specify our database name, which is Ktor Auth again. So make sure to choose the same one as you chose here. We could also just make this simply a name, like DB name is Ktor-auth. Then we replace this here, DB name, of course, and here as well. And I think that's actually it. Let's actually just run our project just to see if this connection works. So I just click run and we should wait a little moment. There we go. And it doesn't look like there are any errors. So that looks pretty good. And you can see you get tons of logs from MongoDB, which we don't want to care about here. Cool. So what's next? Next up, we actually want to create our actual data source. So we will have a simple and a single collection, which is just kind of a table in terms of NoSQL databases, which MongoDB is. So we just store our users in JSON format. That's all we do with MongoDB. And to do that, we need to specify how a specific user, of course, looks like. So we want to go to our root package and create another package called data. And instead of that, we will have a models package in which we specify this. And let me quickly make sure it doesn't compact these middle packages here, because that's a little bit more beautiful in my opinion. Let's create a class here, user. And that will be data class actually. And now, well, what kind of information does a user have? That's simply a username of type string. That's, of course, a password. And we also want to store something called a salt. I will get to this when we get to the hashing part to not further confuse you here. But that's something we also need to store. And we need an ID, a unique identifier for each user, which is of type object ID when we use kmongo. And we can set that to a new object ID, which will generate this object ID randomly for a new user. And we want to annotate this ID with @bson_id, just so that Mongo knows that this is our ID property. So next up, we actually want to create our actual data source. So the data source means that is an interface in which you specify the functions we want to use to access our database. So what do we need? We of course need to be able to create a new user when we register, or we need to be able to find a user when we log in. And for that, I will actually rename this models package, pressing Shift and F6 to just user. So I will just put everything in the user package here, including the new file, user data source. Selecting interface. And that will just contain two suspend functions. On the one hand, find, or let's call it get user by username. Because of course, when we log in later in our app, we need to find a user by its username and then check if the password the user entered actually matches with the password of the user that we got from the database. And here we need to provide the username, and it will return a nullable user object. So it will return null if there is no user with the username. And we need a suspend function, insert new user. So to insert a user, to register them, we need to provide the user we want to insert, and it will return a Boolean whether that request was actually successful or not. And by the way, the reason I make this an interface and not directly implement these functions in a class is that you should always rely on abstractions in your code. An interface is such an abstraction because it does not specify any specific behavior. Just from looking at this file, we don't know yet how what kind of database we actually access. This doesn't tell us anything about MongoDB, and that just gives us a lot more flexibility when it later comes to swapping out a whole database, because then only the implementing class here would change and not the rest of your code base, which would rely on this interface instead, not on the implementation. And it makes testing a lot easier, which we don't do here. But I just want to show you a scaling solution, not just a solution that works. I want to show you one that you can easily implement in your own project without breaking any existing architecture. So inside of the user package, we will now create a Mongo data source, Mongo user data source actually. And that will be a normal class implementing this user data source interface. Now we can press Ctrl-I to actually implement these two functions. Get user by username. Well, how do we now get a user from our MongoDB given the username? First of all, we need an instance of our database. So private val, let's just make this a DB here, of type coroutine database. That is exactly what we created right here. So this is the instance we will pass to this Mongo data source class. Then we can get access to our users collection using this database get collection, and we passed user as a type. And this will automatically create a collection, like kind of a table, not really a table, but just a collection of documents, we say in NoSQL. So a collection of JSON files that store our user data. And if that's called for the first time, which it will be for the first time. And then we can say we want to return users find one, because we want to find a single user with this specific username. And we want to check the user document username is equal to, and import this, the username we pass. So that is how we do queries with kmongo, with this way of writing this. So we specify that a specific property of a specific class is equal to our username. And there are different operators. We don't only have equal, but in our app, we're totally fine with that. And then when it comes to inserting a user, we simply want to return users. So we take our collection again, want to insert one user. We need to pass that as a document, as a parameter, which is the one we passed here. Then we can say was acknowledged. So that will return whether that insertion was actually successful or not. And that's already it for our Mongo data source. That's super easy how we can now use this database. You can easily extend this. Of course, if you have other collections, you create another data source for that, just to make your code scale and to keep these classes to make sure that these classes still have a single responsibility. Now, let's just see how this would now work. In our application, let's just create our user data source here by saying that is a Mongo user data source, and here we pass our DB instance. And now just when we launch this, I want to launch a coroutine in global scope, which you usually shouldn't do, but this is totally fine to just insert a sample user, because we just need a coroutine here, since that's a suspend function we use. Then we create a user equal to user, and we say username is equal to test, password is test password, and the salt, let's just leave that at salt. And then we say user data source dot insert user. Actually, we also want to make sure that this is a private val. You don't want to be able to access this user's collection from the outside. And we say dot insert user and pass our user. If we now launch this, our application, so this code is fired again, and wait a little moment, hopefully everything should just work fine. So I don't see any errors, and let's actually take a look in Mongo Atlas online. I want to click on collections in our cluster, and you can see here is our first test user that we now created. So everything is working perfectly fine with MongoDB. Our setup is correct, and we can actually now go on with, I think, the JWT stuff. So to show you how JWT first of all works, because that's something you need to understand if you use this authorization mechanism. There is a very cool website called JWT.io, and here we can experiment with that a little bit. So here you can see that is such a JWT token. So what exactly is JWT? It stands for JSON Web Token, because it's a token that stores data in form of JSON. And compared to normal session tokens that backends often use, the advantage of JWT tokens is that they are stored client-side. So normally if you have a session token, that is managed by the server. However, if you have a very large backend, then it could be that you have multiple kind of clusters or multiple parts of your backend that run on different servers. And if you then have a session token that the server manages, it might be managed by one part of your backend, but the user talks to the other part of the backend, And that doesn't know about the session. So that is a disadvantage of these session tokens. So you would need to solve that by having a separate authentication server or so, but then that could also be overloaded. So it comes with a lot of complexity when your backend scales. And JWT tokens store client-side. So your server just sends the client the token and then doesn't care about the rest. And once the server then receives such a token, they can easily verify if the token was changed or not. Because of course, if the token is kept client-side, the client can easily change it. But then the server would detect that and would not allow the user to log in. Let's just see how this looks like. So we have 3 parts of this token. The first one, the red one here, is, as you can see, the algorithm and token type. So that just specifies how this token is generated and what kind of token it is, just a JWT token, of course. Then we have this valid part, which is the payload. That's interesting for us because we, of course, very often want to store some information in that token. For example, a user ID is a very common use case of storing information in a token, because once the user actually makes a request and attaches this token, the server, of course, needs to find out which user made that request. And if we change these fields here, the whole valid part will actually also change. And that is the cool thing about JWT tokens, because it uses some kind of hashing mechanism behind the scenes. So if you just change one letter, the token will look completely different. So you can't just change a little bit and it will still work. No, the server will detect that. So we could have something like a user ID. You can see everything here changes. And the value would be, for example, ABC. And then once the client attaches this token to the server can actually check this user ID and actually get that user with that ID from the database or so. And then we have a signature, the blue part, which contains some base 64 encoded values, for example, from the header and the payload. And then we have a secret. So every token was encoded with a specific secret. Only the server knows. Of course, if the client would know this very last secret, they could just generate their own JWT tokens, which look exactly the same as they got from the server, and then they could easily hack this. But since only the server knows the secret, the client can't easily do that. And if we change this, you can see the whole token, of course, changes with every letter we type. So that's the theory behind this. Let's just implement this in practice. Going to our Ktor backend. And for that, I want to create a security package. Actually, a package in our root package. And inside of that, I will have a token package. And here we first of all want to specify a file called, or a class called token config. That will be a data class which summarizes all the fields we want to have for our JWT token config. On the one hand, that is the issuer. So who issued this token, which is in our case just the server. We then have the audience. All these fields are not super important here when it comes to verifying these tokens. But for example, the audience could be your normal users. It could be your admin users, so that you have different types of token for different types of audiences, of users. And we have a variable expires in, which will be a long, because every single JWT token has an expiration date, which is just another layer, another security mechanism, you can say, that makes sure that at some point a token expires and then someone can't log in with that again. Instead, they need to regenerate another token. And we finally have the secret, which the client does not need to know and should never know. So just that we have this as a data class here to summarize this. We want to have another data class in the token package, which will be called token claim. What is a claim? Well, it's in the end just a key value pair that is used to store information in a token. So we have a name and a value. And yeah, that's, for example, we used in the way that we say, okay, the name is user ID and the value is whatever the ID of our user is. So that's what I showed you on the website. We can use this token claims to store key value pairs of data in the token. Cool. Next up, we want to create an interface called token service. And this interface will abstract out how our JWT token generation logic works. It will just have a single generate function to generate a token. And to be able to do that, it needs to know, on the one hand, the config for that, which is of type token config. And on the other hand, a variable number of claims, token claim. So we can attach as many claims as we like. Well, actually, I'm not sure if there is a limit. I guess at some point there is a limit, but I'm not sure. Maybe not. I'm not too deep into these tokens. But anyways, let's return a string here, which will be the generated token. And then we write a class that implements this token service to actually implement this generation logic. So in here we have our JWT token service. And by the way, every time I call something a service in software development, that's usually just a way to call a class that is stateless and just provides functionality for other classes. So here we just have that functionality to generate a token, but this class does not keep any kind of state. So we don't have any member variables here or so. We just want to make sure to actually provide functionality for other classes by implementing this interface, pressing Ctrl I, and returning JWT.create. That is how we create a token. And now we need to configure that. We say with audience, we pass the config audience. We're going to say with issuer, we pass config issuer. With expires at, and here we need to pass a date. So we create that, and well, we now need to provide the milliseconds at which this token will expire. We will simply use the current milliseconds and we add our expires in there. So if expires in is 1 year, for example, then we add that to the current milliseconds and we get the milliseconds that will be in 1 year from now. We actually want to also add our claims that we passed. We can use with claim for that. However, we have potentially many claims, which is why I want to leave it like that. And actually just store the token here in a var. And then we say claims for each claim. Then we say token is equal to token with claim. Claim.name, claim.value. So that is just that we add such a claim for every single claim we have here in our var arg list. After that, we say we return this token with all these claims and we sign it. So that way we actually create the token that returns a string, and the algorithm, let me quickly take a look, is algorithm HMAC 256. That's the one we will use here, and that takes a secret to generate this token, to sign it, and we get that from our config, that secret. And that's how we generate a JWT token. That will be done every time a user logs in. And then we will attach that to the response, and the client can store that in preferences or so. So now that we have this token logic, what comes next? Before we can actually sign up new users, we need to have another security mechanism here that I already teased a little bit, and that is called hashing. So we don't necessarily need this to make this work, but in every normal project you should do this. Just that's a completely normal security practice everybody should use. So let's quickly go through what hashing is and how this works. Well, if we take a look in our database, then we will see that currently our passwords for users are stored in plain text. Now let's imagine your backend is hacked by someone and they find your whole database. Then they will immediately find all the passwords in plain text so they can get all the users' data and log in with these credentials. That would be terrible. We don't want to do that. We don't want to have that danger. So what we instead do is we apply a hash to this password. A hash in the end is just a one-way function that converts your password to a very long and unreadable string. One-way functional means if we have this long unreadable string, we can't convert it back to the password. So it's not like Google Translate that you can kind of translate in both directions. No, with a hash, we can only translate from one language into the other, but not the other way around, you can say. You might wonder, how do we then get the password back? The answer is we don't, because we don't need to get it back. So we store the actual hash, the long unreadable value, in the database, and then as soon as the user actually logs in with these credentials, for example, they use the password 123456, then what we do server-side is we hash this password the user entered, and we compare the different hashes, because the hash value for one of the same password will always be the same. And if these hashes are actually the same, we know the user entered the correct password. And that's also the reason why Google and all these big companies, and hopefully many small companies, don't know your password that you entered, because they just store the hash of it, and with that you can't do anything. However, just hashing is not secure enough. One more concept that I also teased a little bit here is called salting. So let's now imagine you have a super huge user base, and you properly hash the passwords, and an attacker finds this user base. Then they will find all the password hashes, and what they will just do then is they will take lists online. You will find these very easily with the 1,000 most common passwords people choose, and they will hash all these passwords, the most commonly used ones, and compare it with your users. Like, they won't find every single password, but those users actually who use the most common passwords, then they will actually be able to find these users' passwords. Not good. So what we do is we apply a salt. So that is just a randomly generated string that we attach to the password once we hash it. So it will just be a totally different hash than just for the password the user entered, if that makes sense. And then we store the actual password hash together with the salt that we generated in our database, and that way it is now a lot more secure, because the attackers can't just use these rainbow tables, it's called, just a table or a list with commonly used passwords, because they would need to still recalculate every single hash, because you applied a random combination of characters to it, and this hashing process is of course very CPU consuming if you do this for a whole database. So that is what you should do. I hope that made somehow sense. That is why we have the salt field here in the user class. And we'll now actually go to security and also have another package called hashing. And in that, we will create a class called salted hash data class. And that will just summarize a hash and a salt, which we'll then use for another interface called hashing service. And again, that will be a service, since it just only provides functionality for other files. On the one hand, we have a function generate salted hash, because that's exactly what it should do. And it will need a value, so that will be the password later on that we want to hash, so the password the user entered in plain text, and we now want to make it unreadable. And we want to be able to pass a salt length, which I'll default to 32. So just how long the string of the salt will be that we generate. And that will return a string, which will be the hash. And we also want to have a function to actually verify a specific hash. So again, we have a value, which is the password the user entered. And then we have a salted hash, which we get from our database, so what we stored. And this function should either return true if the user entered the correct password, or false if they entered the wrong password. Then let's go to hashing again and implement our hashing. Actually, we call it SHA1, not 1, 2, 5, 6. That's the algorithm we use for hashing, and we call it hashing service. So that way we just know what kind of hashing service that is. And since we made that an interface now, we could easily extend this with other types of hashing services. For example, just another algorithm or so. So we say hashing service, Control-I, Control-A, enter. And now let's see how it would work to generate this salted hash. And by the way, returning a string is wrong here. We of course want to return our salted hash class also here, because we need to know both the salt and the hash that we generated. So first of all, we want to generate the salt, and we can use something called secure random for that, which is a secure way to generate random numbers. The normal way to generate that is not secure. I want to say get instance, and we specify the algorithm we want to do that with. Let me quickly write that off. That is SHA1PRNG. Make sure to spell it the same way. And then we say that generate seed with our salt length. So all that line really does is it generates a 32 character long random string in a secure way. And then we say val salt as hex, because if we now take a look here, that is actually a byte array range. And that's not what we want to store directly. We want to store it as a string. So we can say hex to convert it to hexadecimal. And that comes, for example, from this Apache Commons library. Dot encode hex string. Here we pass our salt. Now we have that salt as a string. And the next thing is, of course, that we need to calculate our hash. So val hash is equal to digest utils, which also comes from Apache Commons codec, dot SHA256 hex. That's the algorithm we use here. And the data is actually our value, because that's the password we entered. We want to hash it, save it in a variable. And we not only want to hash this password actually, because we of course want to use the salt together with that. Because just doing it like this would result in, if the attacker comes over and hashes the same password, like 123456, they would get the exact same hash. They would see which users actually use that password. That's not good. However, we generated the salt, which we'll simply attach before that password value here. And now, since we concatenate these two values, it is something completely different than just hashing this single password. And since we keep track of the salt, we can always just attach it before the value the user entered, and we will get the same hash values. Then we can return a salted hash, the hash being equal to hash, and the salt being equal to salt as hex. So that's one function for that. Now we want to verify this, which is easier. We want to make sure to just return digest utils dot. Again, we want to calculate this hash value with this algorithm. Here we now say we take the salted hash dot salt and we add the value. So now we just basically revert what we do here. So here we attach the salt before the value. Here we of course also need to do that with the password. And that, if that now actually, that hash value is the same hash value as this function here returned and saved in our database, then we know it's the correct password. So we can compare this with salted hash.hash. Then that's it for this hashing service. Now we are actually finally ready to implement our authentication routes so that our client can then access these. Let's first of all go to our application and create instances of the services we created here. So val, on the one hand, token service is a JWT token service that does not need anything. We then want to have a token config object here, which we get from our application config file that we have here in our resources package. We need an issuer, which we can get from environment config. That is how we access this application config file. Get the property. It's called issuer, actually JWT issuer. That gets string. So that will then simply, access the issuer that we will now add here. So issuer will just be HTTP 00008080. That's just the local IP of the server. So we know this server actually issued this token. The domain, yeah, we can actually choose the same because we don't have a domain name. The audience, I'll just call this users. And the realm, yeah, that is just to tell the client what kind of server it is kind of. So I'll just leave it as it's Ktor sample app. That's really not important. And then we can go back. Here we say audience is actually also environment config property JWT audience get string. Then we have the expires in. I will give it an expiration date of 1 year. We can later on decrease this to test the expiration logic. So times 1000 milliseconds times 60 times 60, I think it should be. So this would be 1 minute. This would be 60 minutes, so 1 hour. Then we have 24 hours per day. And we have 365 days per year. So that's now the millisecond equivalent of 1 year. And we have the secret, which we get from our environment variables as well, since we don't want to put that in our config file, which might land in version control, like GitHub. So we just say JWT secret. Now let's go to our application KT, drop down again, edit configurations. We can add a semicolon here to specify another environment variable, which is JWT secret. And here you want to choose something that is, that your clients actually don't know. I'll just choose something super trivial here. For a real server, you choose something a lot more complex, please. Clicking OK. We're going to create our hashing service. That's an SHA-256 hashing service. And then we are good. Then we want to take this token config and pass it to security. And we'll use that to actually set up our security feature. So here we say we have a config, token config. We remove this environment. We can remove this. We can leave the realm. Let's just leave it at this, at configure security.environment, because we don't store this in our token config. And then we have a verifier here in which we need to pass our secret from our config audience. And here we have the config.issuer. And here in this validate function, we actually check whether it's a correct token. So if the credential payload audience contains our config audience, then you can see Ktor will respond with this JWT principle, which is just an authenticated user here in terms of Ktor. So that works. In here, we still get an issue because it's called token config. And now the rest is actually something we will pass later once we have our different HTTP routes, which we will now work on. So in our root package, I'll create a new file called auth routes. In Ktor, we specify these routes by simply making them extension functions. That's pretty cool. So for example, route .signup. And in here, we now specify our route. Well, sign up is definitely something to post. So we say we have a post request since we want to create a new resource on our server. And we specify the URL at which we actually want to be able to do that, which is just sign up here. And in here, we can now get access to all the stuff a client actually attached to the request. Another good thing is that we now already have all of our different services for generating JWT tokens and hashing and have our database set up. So these routes here will be very straightforward. First of all, we want to make sure that we actually have access to our different services we need here in our route. On the one hand, that's the hashing service. Because of course, if we sign up a user, we want to store the hash and salt in the database. So we need our hashing service and we need our user data source, of course. And here it's important that you actually provide the interface type as an argument and not the implementation type, because that way, if you, let's say, swap out your MongoDB with a PostgreSQL database, then only the implementation of this user data source would change and nothing would change in this signup function. So first of all, we want to get the request the client actually made. And to actually parse that into a Kotlin data class, we will go to our data package, and I'll just, let's make it a package, call it requests, and in here a file called auth request. So that's just a Kotlin representation of what the user will provide once they register and log in. On the one hand, they will provide a username and of course a password. And since we want to be able to serialize this with Kotlin X serialization, we need to annotate it with serializable. And let's also directly make another package for responses. So what our server will respond with. And in that, we want to create a class auth response. And that's a data class. And all that contains is the token the client needs to save. And serializable again. Then in auth routes, we get the request using call that comes from this post lambda block here, which refers to the request the client made. I want to say receive or null. So we now specify a type of class we want to parse that JSON post body into. And if it fails, so if the client had some incorrect data that it attached, so it can parse the JSON data into such a Kotlin class, it will return null. You can very easily catch that with the run expression. And in that case, we just want to respond here, saying call.respond with bad request and return out of post. Then just to show you how you would do some normal validation here, I won't add any very super fancy validation here for the data, which you should of course add if it's a real project. But for example, what you want to check is are fields blank? So if the user might have provided an empty username or so, we can simply check that with request username is blank or request password is blank. We could also check something like is password too short? That would be request password.length is less than, let's say, 8 characters. You could check if it contains special characters. You could check if a user already exists, which is all stuff I won't do here. We just want to say if either fields are blank or the password is too short. I want to tell the user, like the client, there's some kind of conflict. Respond with conflict and return at post. So usually you would also provide error messages here, of course, which you could simply attach here as another Kotlin class. So an auth response, which contains also an error field, for example, and the client then parses that. But for simplicity and because the video is already so long, I will leave this stuff here away. However, what is next? At this point, if we haven't returned in this function, we know that the data the user provided is correct, so in a correct format. So now we actually want to take our hashing service and we generate a salted hash out of the user's password. So val salted hash is equal to hashing service, and that generates salted hash. The value is request.password. Then we can create a user object out of that. So equal to new user. The username is salted, actually not salted hash, that is just request username. The password is salted hash.hash. And the salt, which you of course also need to save in order to check later if the user entered the correct password, that will be salted hash.salt. And that user will now be inserted in our database. So we can check if that was acknowledged. Was acknowledged is equal to user data source, insert user, passing that user instance. And if that was false for whatever reason, which should very rarely happen, but it could, then we also want to tell the user, hey, there was some kind of conflict server side, and return here. And if that was successful, so if it was acknowledged, we finally want to respond with just okay, not okay HTTP, just with HTTP okay. Like that. So that will just make sure the client will receive a successful response and they know the sign up was successful. Cool. So next up will be signing in, which we will do just below here, because this file will contain all of our auth routes. Route sign in will also be a post request called sign in. So that's the endpoint. And in here, we're going to have something very similar now. Okay, how will we go on here with the sign in route? We will actually go ahead to the signup route and we will copy this block of code, since that will stay the same. In case the user provides an invalid auth request, we want to respond with a bad request code. And then after that, we want to find the user in our database this user tried to log in with. So we can say val user is actually something we get from our user data source. And we again need our hashing service, and we also need our token service. And then here we will simply say user data source, get user by username, and we provide the username, the user attached to the request. And if that user is equal to null, that means we did not find a user with this username in our database. Then that means, okay, it wasn't found. We want to respond with, yeah, let's do conflict again. You could again attach an error message here, for example, incorrect username or password, but we're not going to use this or fetch this in the app, just in case you want to know how to attach that here to the response. We return at post, and then what do we want to do next? If we actually reach this point in our code, we know that the user with this username at least exists. But we don't know yet if the passwords actually match. So how do we now check that? Well, we can say val is valid password, and that's equal to hashing service.verify. So now we use that verify function to actually compare the hashes. The value will be request password, and the solid hash will be a new instance we create here. So that is now the already hashed value that we get from the database. We want to say the, what do we need to provide? The hash is user.password, and the salt is user.salt. So what this hashing service will now do is it will take this salt, prepend it to this entered password from the user, hash it, and then it will check if the hash, the result of that, is equal to the hash we stored in the database for that user. Hope that makes sense. So if this is not a valid password, we again want to respond with this stuff. If it is the valid password, then we know the user now successfully logged in. So what do we do in this case? Well, in this case, now our token service comes into play, because now when the user logs in, we want to generate a token, want to attach it to the response, so the user can then save it in preferences. So val token is equal to token service, generate. The token config is actually something we also want to provide here as a parameter. Token config, and we have some claims, actually just one here, which I'll just show you how to do that. The claim name would be user ID. So we could save the user ID in the token. As I said, you can save pretty much anything in that claim. And the value will be the user.id. And what's wrong here? Actually, because that's an object ID, we need to say that to string. So that way we just save that user ID in the token, and whenever the user makes the request, we also get the ID out of the token the user attached, so that we can easily fetch data related to that user. I want to say call.respond status is okay, and the message that we now want to attach will be an auth response, because we now want to attach the token to the response, so we can say token is equal to token. And Ktor will then automatically parse that to JSON and send it back to the client. So those are our two most important functions and routes here. There's actually one more route missing, actually two more, but the one yeah, let's actually start with one more. And that will be a very, very, very simple one called authenticate. So what will this route be for? Well, it will be used to authenticate the user. Let's say the user now successfully logged in. Then what we will do is we will generate the token for the user. We will attach it to the response, and the user will save it in preferences. So far, so good. But what if they actually relaunch the app? They don't want to log in again. They actually want to stay logged in, just like in all these apps like Instagram, Facebook, and stuff like that. So we kind of need to attach the token to a request once the user opens the app and check if that token is still valid. And that is what we will that is why we have this authenticate route here. So usually during the splash screen or so, you just make a request to the server behind the scenes to this authenticate route. And this route will just check if the token the user has saved in preferences is still a valid one. And we can very, very easily do this by just saying authenticate get, and we give this a name of, get and authenticate. And in here we say call.respond, okay. So let's try to understand what this does. This authenticate block here in Ktor will make sure that our default authentication mechanism is used to verify if the request is an authenticated request. So if there is a valid token, this will automatically check all that token stuff behind the scenes for us, since we actually set that up here in security with this JWT config here, which we can actually format. Backend auth routes in here, so we have a get request. We directly respond with OK. You might wonder, why do we directly respond with OK? We actually want to check if the user is authenticated, but that will already be handled by this function. If the user is not authenticated or authorized, then this function will already make sure that Ktor responds with the unauthorized status code. And if everything succeeds, the server will respond with OK. So then we know everything went well and we are still authenticated. And if the client sees, okay, I'm not authenticated anymore, then they need to direct the user back to the login screen. So they need to relog in, or you save the credentials of the user in some kind of encrypted format and automatically relog in and get another token. And I want to show you one more thing that won't be relevant for the app, but I want to show you how you can actually now get this user ID from the user who is authenticated. So I want to just have a route get secret info, which is only for users who are authenticated. So we again have this block, authenticate, we get request secret. And in here, we just want to respond with the user ID of the user who made the request. And the user ID is contained in the token. So we can, first of all have to get an instance of this principal. Remember, we had that in security. Here, this JWT principal, which is just a wrapper around an authenticated user, you can say. And with that, we can get access to the claims. So principal is called a principal of type JWT principal. And then we can get the user ID from principal get claim. I want to get the claim user ID, which needs to be the same as we choose when we sign it. Where is it? Sign up, not here, actually here, user ID, this one. And we need to say what type of object that is. That's a string. There we go. And then we can say call.respond. Okay, and we attach the message. Your user ID is the user ID. So if there is an authenticated user, that route will respond with this message. Cool. That is pretty much everything we need for our server. Let's make sure that we set it up that it actually runs, because all these functions are unused currently. To use them, we need to go to routing. And here in this routing block, we need to call these functions. So we on the one hand call sign in, and actually let's get all these dependencies in here. User data source, hashing service, token service, and token config. And then we say, okay. user data source hashing service, blah, blah, blah. Sign up. Hashing service user data source. We have authenticate. And we have get secret info. Cool. Now back in our application file, we want to pass these values here. Configure routing will be user data source, blah, blah, blah. And that's it. I think that's it for the server. So I would suggest we just try this out, and we will use Postman, which is a program to simulate HTTP requests, because we of course don't have our app yet to do that. Let's run this and hopefully nothing crashes. There we go. Looks like everything works just fine. And what I will do is I will switch to Postman to simulate that HTTP request. We want to select post here as a method. We want to enter our server URL, which is just running locally right now, so we can use localhost, and here it already suggests that from my preparation. Sign up first. Want to attach a body, which is the JSON body, which is like raw JSON. And in case you don't have Postman, you don't want to follow along, by the way, you don't have to. This is just to check if our server works before we jump into the building the client. I want to submit a username. Let's say test user 123, and we have a password. Let's say test password 123. If we now click send, that gives us okay. That's a good sign. So the sign up seemed to be successful. Let's try to sign in with these details now. Swap that out with sign in. The body will stay the same. And that seems to work. Here's our token, which the server now responded with. And now we want to check if the token actually works by using our secret route. That is a GET request. And if we access that without attaching any token, click send, you will see it gives us 401 unauthorized because we don't have access. We're not authorized. We aren't allowed to access this page or this data. However, if we go to headers and we attach a header called authorization, and we attach our token to this header, which we can do by typing the keyword bearer, and then following that up with the token the server responded with, and then do send again, then it suddenly is okay. And it tells us your user ID is this. And that's exactly the user ID we save. We used for that user in Mongo Atlas. So if we take a look, so remember this user ID, here's our Mongo Atlas. If we click refresh, then you can see here's our test user, and it has a pretty unreadable password because it's hashed and a pretty unreadable salt. But the sign in still worked. So it seems like our server is working perfectly fine, and we're now ready to jump into Android Studio and build the app for that, which will be a lot less complex. So I'm now in Android Studio, this time not in an empty project. So I will basically provide you the UI here for the simple login and registration form, because I really don't think we need to go through this in the video. If you want to learn how you can build UIs, I have plenty of videos and playlists about that, but that really doesn't have anything to do with authentication, JWT Auth, which is why I decided to provide that. You can get that in my GitHub repository down below. Just clone it and you can start right from there. Yeah, let's just have a quick walk through what will be contained in this initial project, because the video is already so long. I didn't want to make it even longer here. So in the Gradle file, we have our dependencies, view model compose, just for view model stuff. With Dagger Hilt, we will use that for dependency injection. Retrofit, of course, to talk to our server, to make HTTP requests. And we have the amazing compose nav destinations library, which we will use for navigation to our secret screen. If we take a look at our UI package, we will start on this auth screen. And that is really just the screen that I showed you in the preview. It really only consists of text fields and buttons. And I also already have this auth state class here, which just wrapper around everything that can change on our auth screen. So the text field values and is loading Boolean. We have auth UI event, which are the things a user could do on the auth screen. Those are the events we send to the view model from the UI. So either if they change the text fields, or if they click the button, depending on what kind of button and text field. And that's pretty much it. So yeah, our view model here is super empty, just the typical Hill stuff. We have a state so that our auth screen doesn't give us any errors. And we have an empty on event function. The rest we will actually implement here, of course. And we have a secret screen, which just displays here authenticated. Cool. So what we will start with, I already have an auth package here in which we want to start to create our token response, for example, data class. Yep, let me add that to Git. And that will just have that token string, will just be the same as we have server side. We will have an auth request, which we'll use to send to the server once we log in. Password like this. And then we actually don't need any more request and response types. We can next of all implement our API interface with retrofit. And that won't be a tutorial here on retrofit, I must say. I have another video about that if you have absolutely no idea what retrofit is. But I think if you watch some of my videos, you will have an idea of what that is. Just a library to make network calls. We will use it here to implement our auth API, which is an interface. Here we really just define the different functions and different routes we want to access. Suspend function, since that should be executed asynchronously in a coroutine. Sign up, that will have a body attached, and this body will be an auth request. Let's specify a route here. That's a post request, and it will be made to sign up. Does it return something? No, actually not, because we just care about whether that was successful or not, and then we don't need a return type. Then we have another post for signing in. Suspend function sign in. Body will again be an auth request. And here we do get a response, which is the token response, because that endpoint responds with a generated token after we signed in. And then we finally have the authentication endpoint, which is a GET request. Authenticate. Do we need some parameters here? Yeah, we do. We actually need to attach the token here for this endpoint. So we need to tell retrofit, hey, please take the token we saved in preferences and attach it to the request. And we can do this by specifying a header here, calling that header in authorization, just like we did in Postman. And then this will be the token. If you have a lot of authenticated routes in your app, then you might not want to do this. Instead, you might want to define something called an interceptor, which will just make sure to attach your token to every single request that's made to an authenticated route. But for this example here, I'll leave it like that, which is totally fine and will work. Next up, I want to create a little repository to just do all that response handling and error handling. Before that, I actually want to create another class in the auth package called authResult, which is just a little wrapper class to differentiate between whether we are authorized, whether we are not authorized, or whether there was some other kind of error coming from the API. That will be a sealed class, actually generic sealed class, and we're going to attach some data here, which could be of any type, and by default we don't have any data. So then, we do have a class authorized in here. Like this. Here we also specify that data is equal to null, and that's of type auth result, passing our data. Auth result of type T. We can duplicate this. We have unauthorized. Here we don't want to attach data. We only want to attach data in the success case, like our token, for example. And this one will be, how do we call this? Unknown error. Just like that. Then we want to create a repository in here in our auth package called auth repository. And I will do that in any type of project you have authentication in. Just an interface here again that serves as an abstraction for our actual repository, which just makes testing a lot easier. And in here, we're going to have 3 functions. Sign up, which will take a username and a password, and will return an auth result of type unit. We don't care about any type of data. I don't think we will care about data here anyways, but just that, yeah, I wanted to show you a way that would scale, and usually you have some routes that also respond with data, so you can attach that in the authorized case. So we have sign in, username, password, also returns auth result of unit, because we will directly just store the token we get here in preferences. That's why we don't need to attach that as in the auth result. And we have the authenticate route, which does not take anything. And auth result unit. Then let's write an implementation for this repository really quick, which is really not difficult. Auth repository implementation. Make sure to implement this interface. And this actually also needs an instance to our API, which we'll later on inject with Dagger Hilt. You can press Ctrl and I, implement these 3 functions, and start with sign up. Here we want to return a try and catch block. We just want to make sure that we catch all our exceptions from our API. For example, HTTP exceptions, because those are actually relevant here for us, because if we are not authorized, we will get the error status code here in this catch block. So if e.code, the HTTP status code, is 401, which means unauthorized, we want to return auth result that unauthorized. And we don't need to attach anything else. So if the request failed, but not because of an unauthorized status code, we just want to say unknown error. And of course, in a real app, if you want to do more fine-grained error handling, you can check all the different types of error codes your server could throw, and then give the user a really specific error message, like, okay, something on the server went wrong. Okay, something from the client went wrong, or so, which you probably don't even want to show because that's just too technical for the user. But if you want to check these errors in a more detailed way, maybe to do some specific error handling in your app, then you can do that here in this catch block. However, there could also be some other types of exceptions we want to catch, in which we just respond with auth result unknown error. In the try block, we want to say API sign up, and the request will be an auth request where the username is our username we passed and the password we passed. And then we're not done yet, because what I want to do is, as soon as the user successfully signs up, we also automatically want to sign them in. So once we do that, we can simply call sign in with the username and password. And then we're good. So we actually won't reach this point if this fails, because then it will jump into one of these catch blocks here. So if we reach this point and this also does not crash, does not throw an exception, then everything is successful. So next, let's take this, copy this, go to sign in, paste this here. And here we of course don't want to call sign in recursively, but the catch blocks will stay the same. In here we will say sign in, which will give us the response this time. And now we want to take this response and actually save it in preferences, because we want to take the token and save it locally so we can attach it to all requests very easily, also if we relaunch our app. So I will inject preferences here. I'll just use shared preferences here. And I'll leave it out to run an abstraction for shared preferences here, which I would usually do in a project. But I don't see the need here in this project. And just to make sure this doesn't get too long. So what we will do is we will take our preferences, say edit. I'm going to put a string called JWT. That's our token. And what do we save? Well, we save the response token and say apply. And if then everything went right, I want to say auth result authorized. And we don't want to attach any type of data. Cool. And one more thing is, let's copy this again, is our authentication endpoint. Let's paste this. Instead of this, we call authenticate. And well, we first of all now need to get the token from our preferences. So we can say prefs.getString JWT default value is null. And if that's null, we want to return auth result unauthorized, because if we try to authenticate and we don't even have a token saved, we know for sure that we're unauthorized because we don't have a token. So we say actually nothing, and we pass the token. Actually, not just the token. Actually, we want to also have the bearer keyword. That's important. Then save the token or add the token here, and if everything goes right, we say auth result authorized. So I hope that's clear. I don't think this is a very difficult class. If anything is unclear, you can always ask me on Instagram, for example, which I just created a very new page where you can also learn a little bit about me and my everyday work life. So I have a personal page on Instagram, which you can follow down below. I will link it. You will find it there. And if you have any questions, you can always ask me in a DM there, which is easier than in YouTube comments, I think, and a little bit more personal. However, now that we have our repository, we can use that in our view model and inject that here in the constructor. Auth repository. And again, make sure to depend on the interface. So let's start with onEvent. Here we get these UI events for every single thing the user can do on our auth screen. So for example, entering some text. We want to differentiate between these events. If that is auth UI event, sign in username changed, we do this. If it is sign in password changed, we do this. If it is sign in, so the button click, we do this. If it is sign up username changed, sign up password changed, and sign up. For these text fields, that's super simple. We just want to say state is state.copy. And in this case, we say sign in username is event.username or event.value. Copy this, paste it here and here. We just need to swap out this name here. Sign in password, just to update our state. Sign up username, sign up password. And now these two are a little bit more interesting because there we of course need to do our network calls. Let's have a private function sign up. Let's start with that. Here we want to say view model scope and launch a coroutine. That launch. And we say we get the result using our repository sign up. And the username will be state sign up username, and the password will be state sign up password. Before we do this, we actually want to say that we are now loading. So state copy, and we set is loading to true. which we can set to false after we made the request. And well, what we now want to do is we want to kind of notify our UI about whether this signing up was successful or not. So we of course want to now do something with this result. And what we'll do is we will create a channel to send these events back to the UI. And that's exactly what a channel is for. Result channel, channel auth result of type unit. And then we convert that channel to a flow. So auth results is result channel receive as flow, which you probably also know from my videos if you have watched some of these. So then we can simply say result channel send result. And this is something we can now very easily copy and paste for our other two endpoints. For sign in, you want to call sign in instead. Make sure we use the sign in username and the sign in password. The rest stays the same. We paste it one more time. For authenticate, we change this to authenticate. And here we don't need to provide anything else. So that looks pretty good. We now need to call these functions, of course. In sign up, we call sign up. In sign in, we call sign in. And when do we call authenticate? Well, we want to call that initially. Initially, when we open our app, we want to check whether we are currently already authenticated or not. So if we already have a token in preferences, then we will automatically log in. So in the init block, we say authenticate. And now the last thing that's at least missing for the authentication mechanism is that we actually listen to these auth result events in the UI. So auth screen. Here we will get an instance of our context because we want to be able to show toast when we receive an error. And we say launch effect to just be able to collect that flow safely. The key, well, let's just provide two keys here. On the one hand, the view model and the context. So whenever one of these two changes, this will fire off again and update. I also have a video about these effect handlers, which I don't want to go too deep into here. I want to say view model, auth results, collect. Here we get a result. We can check when that result is authorized. We do this, unauthorized, this, or unknown error. I think that is the wrong import. This one here. If we receive an unknown error event, we want to show toast, toast.make text, passing of context, passing an error message, an unknown error occurred. So that would, for example, be the case if we entered the wrong credentials. Actually, $R, and we say toast that length along. And again, if you want to check that, or if you want to show that specific error message in the app, which you should of course do in a real app, then you would simply attach that to the response of that login method as some kind of JSON object, and then display that, of course, in the app. I think it should be clear how to do that. And then call that show. Do the same here with a different error. You are not authorized. And if we're authorized, we actually want to navigate to our secret screen. So what do we do for that? We attach a navigator instance here, a destinations navigator, which comes from our cool compose nav destinations library, which makes it super easy to navigate with compose. So navigator.navigate, and we want to navigate to secret screen. We actually don't have that yet because it needs to generate the files for that. The library actually generates a lot behind the scenes. Let's set that up then. We go here, and for every screen, we annotated this with destination. And just for the auth screen, we say start is true, because this is our initial destination. Our secret screen, we'll also get this destination. And then we can actually rebuild our project, go to build, rebuild, to make sure that the missing classes are actually generated by the library. We of course got an error here because I didn't finish this yet, but we should be able to now say secret screen destination. Yeah, that's the generated file. We want to open a block of code here as well, and we want to say pop up to secret screen destination .route, and then open another block and say inclusive is true. So what this will do is, as soon as we navigate to the secret screen, we simply pop the backstack, so we make sure that we can't press back and get back to the login screen, because that's something you don't want to be able to do if you're logged in. Cool. I think that's almost it. Almost. We need to set up Dagger-Hilt dependency injection. Let's create a DI package here. That's a quick thing as well. DI, dependency injection, create our app module. And I, of course, also have a course about Dagger-Hilt. We annotate this with module to tell Dagger-Hilt that's a module. We're going to install it in the singleton component to make sure all these dependencies live as long as the application does. And then we have functions that provide our different dependencies. So we want to provide a singleton, and that will be our auth API. We don't need anything for that. Just want to make sure it returns an auth API. And we say return retrofit builder. Base URL for now will just be your local IP address. Or if you use the emulator, you can also say like HTTP 10.0.22. That only works if you use the emulator, because you can't use localhost here, because localhost on your phone will refer to the phone and not to your PC. So instead, yeah, you're on the safe side if you use the local IP of your PC. Mine is this one. You can check that in your network settings on your machine, or if you're on Windows, you can open CMD and type ipconfig, press enter, and then you will find this. The port is this, and yeah, that's how it looks like. We'll of course swap this out as soon as we deploy this. Then I'm gonna add a converter factory, which is a Moshi one, to be able to automatically parse JSON. And we say build and create. And we can import create here, I think. Can we? Yeah. So we already have an instance to our API. The next one will be shared preferences. Provide shared pref. We'll need our application instance, so the context in the end. And we say return app get shared preferences, give them a name of prefs, and we say mode private, so nobody else can access these. And then finally our repository provides singleton provide auth repository with our API and our prefs. Returns auth repository, return auth repository, implementation, and pass these dependencies. Then one last thing is we need to create an auth app class in the root package, which will be the application class which Dagger-Hilt needs. Like this. Annotate this with Hilt Android app. That's already enough. We then need to register this app in manifest. Here, pass a name, auth app, and what we don't want to forget is internet permission. So users permission internet. And that is it. In main activity, we just need this annotation, the Android entry point for Dagger Hilt. And we of course need to specify our nav graph, which is just one line with this amazing nav library. That is just a destinations nav host with nav graphs. That root, that is also a generated file. Ooh, I think that's not really it. I would say we launch this app on my device. And I will see you back. Okay, Dagger Hilt throws some error. It's probably because we just need to rebuild the project. Let's do that first. And meanwhile, I will check my device and let's try this again. Hopefully there's no error. Yep, seems like now it's working, it's installing. There we go. I also already saw the message "you're not authorized," which is of course appropriate. Let's try to register here, register a new account. Okay, now it works. Let's say Philipp. Password is test password. If we click sign up, we should also already automatically sign in with that, with these credentials, if everything goes right. An unknown error happened. It did not go right. Let's check our server logs maybe. Oops, there's a very long log here. Luckily we have the call logging library or the call logging plugin, which we still can't find. We should be able to search for post, which is still makes it hard to find. Let's just make the request again. Unknown error happened. Yeah, I don't know. Maybe that's an Android error. Let's check logcat. Something in here, maybe warn. Yeah, so I will need to check that again and get back to you once I know more. Okay, I have found the issue, and it's a very dumb one that always happens to me when I develop with local backends. And that is that we need to go to our manifest and we need to add users clear text traffic, set that to true. That's something you should only use for development, but you need that if you actually use an HTTP URL, so not HTTPS. It's not encrypted here. Okay, let's relaunch this. And you're not authorized, you can see that. It doesn't work, of course. And we now try that again. Test password. Click sign up, and yes, it works. You're authenticated. Pretty good. And if we now click back, then that does not work yet. Popping the backstack. Let's take a look after that, why that doesn't work. Actually want to close this, relaunch this, and hopefully it should automatically log in now. Yep, and it does. You just saw the login screen very quickly. Usually you want to have some kind of splash screen to show to the user when that happens, but the mechanism stays the same. Now, if your app would try to authenticate here and the token would be expired, then this screen would not show up because the server would not allow this. So they would respond with unauthorized. In that case, the user would get back to the login screen or actually stay there. If you want to make this automatically happen, then you need to store the credentials after the user logged in, please in encrypted format. You have encrypted chat preferences for that, which is just a library you can use. It's the same as normal chat preferences, just that you need to provide some kind of encryption algorithm or so. It's pretty similar. But I also see many apps not do that. Instead, they just say, okay, your session expired, please log back in. Let's now check very quickly why popping the backstack doesn't work there. In auth screen. Ah, yeah, I provided secret screen. Of course, we need to say auth screen, because this will pop all the screens between these two screens, and the secret screen is not on the backstack yet before we navigate. So there is nothing to pop. And if we say, okay, actually until the auth screen that is on the backstack, and yes, it's also inclusive, we also pop it, and then it will work. So first of all, congrats for making it this far. And now you should also not skip the very last part, which will be quicker than building the app and will be building the backend. I will show you an automated way how you can deploy this with a single click using Gradle. And yeah, then you have a very brilliant way to implement a great authentication mechanism while following all the security best practices, except for HTTPS. That's something I won't show you here. But that's also something that's very easy to implement with Ktor, just by following the documentation. It's actually just adding your certificate in the config file. So I will see you back in IntelliJ to set up the deployment process. All right, we're actually not back in IntelliJ. We are actually back in Google Chrome because, of course, to be able to deploy our auth backend, we need to be able to, first of all, have a server we deploy to. And in regards to server hosting, my full recommendation goes towards Hostinger, which is this video's sponsor today. Why do I like Hostinger so much? Well, you already see it. On the one hand, it is super cheap, just $2.99 a month, and you already get a website. Actually, not just one website, you get 100 websites here. So it's a super fair price. But it's not only that you get a bunch of websites here for your money or a bunch of server resources, it's also that they have a brilliant support. So I had quite some questions here actually when I was setting up the server to prepare this video. And Hostinger's customer support was always super responsive. I always got like an answer within a few hours. So my full recommendation goes towards Hostinger. And if you want to follow along in this video, then I will show you how you can use their website to actually set up your server, to then take our Ktor backend and put it on that server so we can actually also access it from the outside. And if you actually follow along, then please use the link down below in combination with the coupon code Philipp7, because then you can save up to 91% on all yearly hosting plans. So make sure to do that. Go to the Hostinger website, and here we actually want to go to hosting. This is actually the web hosting sale, which we're not going to use because we just want to deploy our backend. We don't have a website. So we go to hosting, and here we want to select VPS hosting. That stands for virtual private server hosting. And in the end, that's just a remote Linux machine we can use and we can control, we can send commands to in the end install and deploy our server on that remote machine. So then, being here on this website, we scroll down to the different plans. You can see this is the most popular one. This is totally enough if you just want to play around. If you really just only want to play around and don't use this with any real user base, you can also use the cheapest version here. I will have this VPS 2 server option here for this video. You simply click select. Then you can see the different options, so the payment frequency. And here you want to make sure that you actually go to have a coupon code, because you do have a coupon code. And you enter Philipp7. Oops, not Philipp Pop, Philipp7. And you click add, and then you will save some additional bucks on that server plan. Once you did that, you have to log in here in your Hostinger web panel, and that is where I will see you back. So here we are in the Hostinger web panel, in which we're now going to set up our VPS server plan 2, which you can see under setup here. Of course, if you just book this VPS server plan 2, then all the rest probably won't appear for you. So that isn't important because that's not relevant for this video. We're just going to click on setup because that's what we want to do. And we click start now. And then we have a very user-friendly wizard here that guides us through the creation of this VPS. Here we want to select the location where we actually want to host our server. Ideally, that should be pretty close to where your users are. I will select Netherlands here. That's just the closest to Germany, but select anything that's near to your location. Click continue. Now we have to choose an operating system that server should run on. We have 3 options. On the one hand, an operating system with a control panel, so you have some easier management and you don't have to do everything with commands. However, we are not going to use this. We will still use this option here, so I can show you how that would work. But you could also just install a plain operating system with no control panel, as you can see, or a game server. So if you want to play Minecraft, you can also host your game server here on Hostinger. Let's choose this one here. Click select. We don't want to use a CentOS distribution in Linux. We want to use Ubuntu instead. So we will choose, I want to choose a different control panel. We scroll down and we choose Ubuntu 18.04 with Webmin. As I said, we're not going to use this control panel, but just that you see which options you have here with pre-installed control panels. So feel free to play around with that. We just want to make sure we have an Ubuntu Linux here on our server. So then we click continue. We now need to set up our VPS host name. So we need to give our server a name. I will call it JWT Auth YouTube.com, for example. We need to select a root password here. This password will be used to actually log into your server. So I will simply enter mine here like this. And then we can click save and continue because we don't want to add an SSH key here. That you could also do that later. There we go. Now it'll have a little summary of what you're actually creating. And we want to click finish setup. And then you can see I have some other servers here from recent tutorials or from playing around. And that is now creating. You can see that will take a little while and I will see you back once our server is actually properly set up. So here we are in the hosting web panel and my server is created. It is running, which I hope is the case for your server as well. So let's click on that. And here you just get all the relevant information for that specific server you need, like all the hardware usage. But what we're interested in the most is the IP address. So we of course need this IP address here to connect to the server in combination with our password we chose. So we want to copy that, and the way we will connect is using SSH. SSH is a tool that we execute in the terminal, and we can use it to simply send shell commands to our remote Linux machine that we have here. If you're on macOS or Linux, you can just use the default terminal because that will work just fine. If you're on Windows, I recommend to actually use this git bash shell because that's very similar as the Linux shell, because we will actually need a command that is not available, I think, in the default Windows PowerShell. So I recommend, if you're on Windows, to download this and then use that for your shell command instead and to connect to the server. I will simply switch to my shell here. And can I make this a little bit bigger? Yes. Very good. And here, let's just first of all connect to our server to see if everything is working. We use SSH and we simply specify root. Okay, that is the user we want to connect with. So just the user we have root access with. And then we paste our IP address. And if we then click enter, then we need to accept this here with yes, that we want to connect. And now we need to enter our password here, which shows in the hostinger setup process. So I will enter that here and press enter, and there we go, we're connected. And now all the commands we enter here aren't executed on our machine anymore. Instead, they are executed here on our remote server we hosted on Hostinger. So how will this now work? So the way we will now deploy our server is, in the end, we will take our Ktor backend and we will package it into a single jar file, because in the end, Kotlin is also just a language that runs on the JVM, the Java virtual machine, and we can run it just using Java. So we will have a way to actually package our server into a single file, an executable Java file, and then we will take this file and we push it to this server where we will now install Java to simply execute it, so that our server in the end runs here on this Ubuntu machine. We need to make sure that it's reachable from other machines. And that's pretty much it. We will, of course, automate all this so that you don't always need to manually push this. And for that, I will show you a very cool Gradle script. And that will be a lot of fun. So first of all, here, if we type pwd, then we just see the current directory where we're at, which is just root, which is the root user. We need root access to actually install all this stuff here. So that's fine. And in this folder, I just want to create another folder, which we will simply put our jar file in later on when we deploy the server. And we can create this using mkdir, so make directory, and I'll call this JWT Auth. If we then type ls for to list the files in the current directory, we will see our newly created directory here. So something we of course need, as I said, is Java, because right now here, let me clear that up here. So right now, if we type Java here, you will see the command is not found because it's not installed on the machine. But we need this Java command to actually run a jar file. So what we will do is, first of all, we want to say apt update to just update the repositories where this Ubuntu machine can get some program downloads. So in the end, we will use this command line here as well to just download Java and install it here on this Linux machine. This will take a little while. When that's done, I will clear this up using Command L, and then we can say apt get install default JDK. That is the default Java version we want to install here. We press enter. We need to accept this using Y, pressing enter, and then it will look like some hacker stuff, and I'll see you back when that is actually installed, because that can take a few minutes. All right, when this is done, I can clear this up again, and now if we type Java, you should see some options, and that means it's installed. So congratulations. The next step is to actually, we want to write nano /etc /sshd_config. So that is basically the configuration file for the SSH service, which we again use to connect to the server. And here we just want to paste one line here below all these comments. Well, let's just paste it here where no comment is, which is this long line. You will find this in a file in this video's description, of course, so you don't need to type this off. What is this line for? Well, it just defines some more kind of algorithms and key exchange algorithms we allow to connect to the server. And later on, when we actually want to automate the deployment process here to the server, we just need this line, because the library we will use in our Gradle file to automate this needs an algorithm that is not kind of allowed by default. So we just include this line. We can then hit Control and S to save this, and Control and X to get out of this file. And then we need to make sure to actually restart this SSHD service. So that's just a service that always runs in the background here. So we can say systemctl restart SSHD. Systemctl is just a command we use to interact with these services. And in the end, we will also use that to create our very own service here for our backend in the end. Let's press enter. And that looks very good. And let's actually do that next, what I just mentioned. So we want to create our very own service. Our jar file will in the end run in. So what's the difference between a service and just normally executing that jar file? Well, if we normally execute it, then as soon as we actually restart our server, for example, then it will simply, that will simply be stopped. Or let's say you also have an error or so that occurs when you launch your server, then there's no mechanism to automatically relaunch the server and retry to start it, because of course you want to guarantee that it is that the uptime is pretty much close to 100%. And for that, just normally executing it in Ubuntu or Linux is not enough. And for that, we create a service, so we have some additional configuration that Ubuntu will actually manage this to actually make sure the service is pretty much always running. And to be able to set that up, we need a configuration file, which we can use, which you can create with nano again. So /etc systemd and then /system. And now we need to specify a name for this configuration file, and this will also include the name for the service, which I will choose JWT Auth.service4. Then we press enter, and it will create that file, because it of course doesn't exist. And I will again paste something here you will find in the description, and I will go through what this means, which is exactly this. So this is how such a systemd service configuration typically looks like. The relevant lines here are, well, the description just to describe a service. It is executed after network target, so after we established a network connection. So Ubuntu will wait until that is the case. And then what else is relevant? We want to always try to restart the service. We want to launch it using the root user. And now these two lines are especially very important. So first of all, this exec start, that defines the command Linux should actually run when we start the service. And you see, all we do is we kind of reference our Java executable, we have to do that with an absolute path here, otherwise this doesn't work in the service. So it's in the end just as we type Java in the command line, what we just did. And then we have this jar option to make sure, or to tell Java, hey, we want to execute a jar file. And here we will simply pass the path to our jar file, which will be called JWT Auth.jar in the folder we actually created here some minutes ago. And to actually make sure that we can also specify some environment variables, because remember we do this for the JWT secret and our MongoDB password, which we don't want to put in our source code. We actually have this environment file variable here, kind of, in which we specify an environment file where we can put in these variables so our Ktor server will find these. So you don't need to change anything in this file, just that you have some basic understanding of what happens here. We can again press Ctrl S to save it and Ctrl X to get out of it. And now we can actually try to run the service using systemctl followed by JWT Auth, actually followed by start, because that's what we want to do, and then followed by JWT Auth, which is the service name. And we don't get any errors, so that looks good. In the service itself, there will be an error, of course, because we don't have the jar file yet, but the service is set up fine, so Ubuntu can actually find it. What we now want to do is want to say systemctl enable JWT Auth. That will make sure that it's automatically relaunched when we relaunch this whole server. So pressing enter, and you can see that worked as well. And something else you typically want to do when you deploy a server is you want to make sure that the port the server is running on is actually open, or that you properly forward some traffic. Because if we just access the server here using its IP address, it will just connect to the default HTTP or HTTPS port, and it won't find our server there because our server is running on port 8080 and the default HTTP port is, I think, 80. So what we want to do is we want to take all the traffic that goes into the 80 port, so HTTP port, and we want to forward it to the 8080 port. So if we just normally access our server, which could be a website, if you just type the IP address in your browser, then we take the traffic and we just forward it to our server so it actually receives that. And that is what we use IP tables for. I will use this command, which you can find in the file in the description. So all we do is we just make sure that we redirect the traffic from port 80 to port 8080. We press, oh no, Siri. We press enter here. That works, and we want to make sure to add 2 more rules, which I think aren't actually needed here on this server, but we want to make sure that these ports are actually open so that external traffic to these ports is allowed. So we just want to make sure that we accept traffic at port 80. Pressing enter, and we want to do the same actually with port 8080 and pressing enter here. So these IP tables just contain the network configuration in regards to which devices or which kind of devices are allowed to talk to our server. We now made sure that every device can at least talk to the port 80 and 8080 and that we properly forward the traffic. So far so good. These configurations here aren't actually saved. So when we reboot our server, we would actually need to reset these IP tables rules. We don't want that, and that is why we will install something that will actually save these rules. And that is called IP tables-persistent. So we can again use apt get install IP tables-persistent. Pressing enter, it will give us this prompt again, which we need to confirm with a yes. And then this window will pop up. Here we simply want to press yes to actually save the IPv4 rules and the IPv6 rules. So just pressing enter twice, and then everything will work just fine. I will clear this up here and we can go on. All right, I think the last thing we want to do here on the server itself in form of configuration is to set up our environment variables. And remember, we had that file for that, which you can access at etc environment. And you can see there is just one path variable here, which is a very common environment variable. We don't need to further give this some attention. We just want to make sure that we actually add our very own environment variables here. And that is on the one hand, JWT_secret, just the same we named these in our Ktor backend. And ideally you want to use something here that is very very long and something you can't easily crack. So I will just enter anything here. And of course, don't show this to anyone like I do here. I show this to the whole world, but I won't do anything else with the server, and I will remove it after this video. But just that you know, this is really secret information that we deal with here. The same as our Mongo password, which is, I think, if I remember correctly, Ktor Auth tutorial. We can, again, simply check these values in IntelliJ. If we go to our application configuration here, then here we have our environment variables that we set up in this tutorial. So the JWT secret doesn't need to be the same. That's just used to sign new secrets. So you know, so the server actually can also decode the JWT tokens that were signed with the same secret. And here's our password. That needs to be the same, of course. So back here, we want to hit Control S to save it and Control X to get out of this. And I think, at least for the server configuration, that's it. So we can simply exit here to get out of this SSH command, kind of, and we're back in our normal terminal. So one more thing we actually need to do before we jump into IntelliJ and set up our automation script is we need to create something called an SSH key. An SSH key is used to actually authenticate to a server using SSH. So since our Gradle script will of course need to access our server, and it will just do all the SSH stuff behind the scenes here, what we did manually to push our server, it needs to be authenticated. And there are two ways that we can provide for Gradle to do that. On the one hand, we could provide our password for the server, which we don't want to put in the Gradle file as plain text. So instead, what we want to do is we want to provide a key which Gradle can use to get access to the server. We, of course, first need to create this key and tell our server that it can be used to authenticate to this server. And we can do this using SSH-keygen. We want to make sure that the type here is RSA. That's just the crypto algorithm that is used to create this key. And we append -m here, PEM, which is just the format of this key. It's important that you do this, otherwise the Gradle script will not know how to authenticate because it relies on this type of key format. We press enter, and you can see we now need to enter the file in which we want to save the key. The default is in your users folder. So there is a .sh folder, and this is the default name for SSH keys, but you can give it a different one. So you want to make sure to save it in the same directory, -users, in my case, Philipp Lackner, and -.sh, how will I call this? I will call this JWT Auth key, or just JWT, let's call it key, -YouTube actually, because I think I already have the other one. Let's press enter. We can enter a password here to additionally save this key. We don't want to do this because then we have the same problem of providing a password. So we don't need to have that password. Just pressing enter twice without entering anything will give you this output. So that key is now created. And if we now actually cd into this directory, so users /Philipp Lackner /.sh, then typing ls to list all of these keys. You can see those are my keys, and here is our just created key. This is on the one hand the private key, and this is the public key. The public key, as the name says, is public. You can share this with anyone, but the private key is not. So the private key we will actually now use in our IntelliJ IDE. So we will use that for the Gradle script to authenticate to our server. And before that, we actually need to put the public key on our server, so it actually knows that the private key here is allowed to access it. So these only work together in combination. And we do this with the ssh-copy ID command, which is not available, I think, in the PowerShell on Windows. And that is the command which I recommended you to install the git bash. However, on macOS and Linux, that's not a problem. So ssh-copy ID, want to specify the key file with -i, which is JWT Auth key -YouTube. And now we need to specify the user and the IP address we want to actually copy this key to. And for that, I will again just copy my IP address here, this one, paste it here. We press enter. Then we need to type our server's password here again, which I will do, pressing enter. And you can see it tells us number of keys added is 1. And now if we simply type SSH here and we try to connect to our server, then that didn't work. But if we provide the password here, the key file actually, so if we type -i and we use JWT Auth key -YouTube, then you can see we can directly log in with that key without actually needing to enter our password. And that is the same mechanism that we will now use in our Gradle script. So the Gradle script can access the server that way with this private key file. One thing we need to do before we can set up the script is, of course, we need to allow our Mongo Atlas to be accessed from our server. Because if you remember here under database access, we added our own local IP address, or not the local one, but the IP address of our machine. And if we deploy our server, the Ktor backend is of course not talking from this machine to our Mongo Atlas. Instead, it's talking to it from the IP address from our hosting server. So here we want to go to actually network access, not database access. Here you will find the IP address. We click add IP address, and we paste our server's IP address. And we can give this a comment of JWT backend or so. And we click confirm. And then this will be perfectly fine. And we can jump into our Ktor server here. So the first thing I want to do is I want to get the key into here, the private key that this backend will now use, that this Gradle script will now use to actually authenticate. And for that, I will go to our root package, create a new directory, or before that, I will actually go to gitignore and add this to this directory I will create here to gitignore, because we of course don't want to push this keys directory into version control because that contains secret information. So we now create a new directory called keys. And in that directory, we now want to paste our private key that we created. So here I opened this .ssh directory, which again you find in your users folder on your machine on Windows as well as on Linux or Mac OS. And here I have this private key here without this pub. We copy this and we paste it here under keys and pressing enter. And yes, okay. And that is already everything we need to do in regards to the key. Next up, we want to open our build.gradle KTS file, because in here we now want to define a Gradle task. So a thing Gradle should do to deploy our server fully automated. I will do this at the very bottom here. And you again find this task in the GitHub repository down below, but of course I will go through it so you understand it step by step. So let me just paste what I need to paste and then I will go through everything. So first of all, we have this here, which is quite some code. We then want to paste a dependency here, which is this one, this SSH and task. Then we want to take this variable above the dependency block here to tell Gradle that we have this SSH and task. We then want to go into this application block, and below this main class set function, we paste this line, which I'll again explain in a moment. And under plugins, we want to paste this line. And then we can click this little load script configurations button to make sure that Gradle will synchronize this. Here it won't know this shadow jar. We can press Alt Enter to import this. There we go. And click this reload or synchronize button here again from Gradle. And now we're actually ready to explain this step by step. So let's start with this plugins block actually. What happens here? We added this line here, which is called the shadow plugin. So it's a Gradle plugin that in the end will just take our whole backend and package it into a single jar file. So the job of this plugin is just to create the jar file we will then take and push to our server. And then the next line we added was this one here. We set a property in our project called the main class name, and we set it to main class.get. For some reason, this shadow plugin couldn't really find the main class name, so the name of the class in which it can find the main function, so in which it finds the function it needs to run our server. And for some reason it couldn't find that, so I actually needed to manually set that property here in the application block, so it doesn't require any further thought. You just need to add this to make it work. Then we have this SSH and task, which we define here. So we create kind of a Gradle configuration, and then we get the dependency here using this line. So what does that do? That is now used to be able to access SSH with Gradle. So inside of a Gradle task, because by default that is not possible, we need this SSH and task. And this will not only give us access to SSH, but also to something called SCP, which is similar to SSH. So with SSH, we actually send shell commands to a server, and with SCP, we actually send files to a server. So we just need these two, because on the one hand, we need to send our jar file to the server, and on the other hand, we need to send commands to the server to just tell it what it should do after we push the jar file. So here we just configure this shadow jar plugin a little bit. That's just the very default configuration where we need to reference the main class here, which we set here, if you remember. So if we didn't do this, it wouldn't have find this here. Here we have and with Groovy Builder, which looks very cryptic with all these quotes, but that's what we need to do since we're in Gradle KTS here, the Kotlin version, and not in Gradle Groovy. We have to do it this way because the plugin actually is only set up to work with Groovy, but luckily there's this with Groovy Builder to kind of simulate a Groovy environment. Nothing to think about here in too much detail. We basically just say, okay, we have a task that is called SCP to just copy a file to a server, and we have a task that's called SSH to just send commands to the server, and it just references the specific classes here that come from this SSH and task dependency we added. The real interesting part now comes in our custom deploy task. So this is now a Gradle task that we can now very easily execute just by using a shell command. So we can then type our Gradle w deploy, and we will deploy our whole backend and update it accordingly. It first of all depends on clean and shadow jar. What does that mean? If we use depends on with Gradle, then it means, okay, these two tasks actually need to run first. So first of all, we clean our project, we delete the build directory, so we just start with a totally fresh build, and then we use the shadow jar plugin, so we wait until that's finished to actually finish building the jar file we want to push to our server. And then again, we use this Groovy Builder here because, as I said, we need to do that if we deal with these SCP and SSH tasks. We define a known hosts file because we just need to attach this here to all these commands. We define a user we want to use to actually log into our server with SSH, which is of course the root here. We define a host, which is your server's IP address. And here I actually need to update this one, and you of course paste your IP address. This is my IP address that I want to use. Here we reference the key, so our private key we paste it here under the keys directory. That is now called JWT Auth key -YouTube. And here we have the jar file name. So after the shadow jar plugin is done, this is how the jar file will be named by default. So you have your package name, so compl coding in my case, you of course use your package name, and then followed by Ktor -JWT Auth, that is how my project is called, -version, so it will paste the version you specified in Gradle, -all, so it just contains everything, all the resources, all the code and all that stuff, .jar. So just that we know how the jar file is called, because we of course need the name to be able to tell this SCP command now to what it should actually push to which destination. And now it's just a logical sequence of steps that we would normally do manually, but since we use the script here, it will all be done automatically. So we first of all want to copy something, that is why we reference SCP. We need to specify the file we want to copy, and that will be in our build libs directory. That is where shadow jar will create that jar file, followed by the jar file name. we specify the to directory, so where we want to push that to. That is our SSH server. So actually not our SSH server, our hosting server, of course. And we reference that using the user at host, just what we did in the shell as well when we connected that with SSH /root /JWT Auth. That is the directory we actually created in the root folder. And inside of this, we want to push our jar file here. We need to tell it, hey, please use this key to authenticate. We want to trust this, and we reference our known hosts file. Next up, when this will go on, if the upload was successful. So this time we want to execute a command. We don't want to send a file. Instead, we want to now tell our server that it should actually run this server, this jar file that we now pushed it. Before that here, I like to actually rename this jar file because I don't like this very long name. We actually want to have some kind of name that we can easily launch on our server. So we first of all rename this. The configuration here is the same just for SCP. The difference is that we can now specify a command, just a shell command, that we want to execute here. And the command is move. We want to move this file to this file. So the move command is in the end just used to rename the file here from this name to JWT Auth.jar. Then again, we go to SSH here. So we again execute a command. This time we want to stop the current service, which is just JWT Auth. That is how we call the systemd service. If you remember this configuration file, JWT Auth.service. So you need to reference the same name here. We want to stop it, and then we want to start it. I think the restart command should also be enough here. I don't know how that works if it's not running, but yeah, with this, we're on the safe side. So again, all we do is, first of all, push the file to our server, rename the jar file, stop the current service, and start the new service again with the new jar file. And if we now synchronize this here, I think we should be able to try this out. I hope everything goes well, and if not, I will look into it and see where the issue is. How do we now execute this deploy task? Well, we go to our terminal in IntelliJ, and we write /Gradle W for the Gradle wrapper, which is used to execute Gradle tasks, and we say deploy, pressing enter. And you can see now it will do its job. Here, first of all, the shadow jar plugin, which will generate the jar file, and now our deploy task is running, which will take a while, of course, to push the file to the server that was generated. And it tells us build successful. That is actually a very good sign because there were no authentication issues or any other issues. So if we now go back to our terminal, we can actually check if that was successful. I will clear this up here and I will connect to, actually I can use the same command here, I think, no. Oh, I am still on that server here, as you can see. So I don't need to connect. I am currently here in the root directory where we have our JWT Auth folder, which I want to navigate into with cd, and now typing ls again, and you can see here is now our JWT Auth jar file that we just generated in IntelliJ, and that was automatically pushed here to our server. And we can also use systemctl status JWT Auth to get information about our server. You can see it's active and running, nothing crashed, that looks pretty good. So what's the next and the last step? We need to try that out in our app, of course. So here I am back in Android Studio, and all we need to do is we just need to change the IP address here to our server's IP address. I don't think I can paste this here. Oh, I still have it in my clipboard. Okay, so we just change our local IP address to the IP address of our hosting server. And we also don't need the port anymore because we forward all the traffic from port 80 to 8080. If we did that, we can launch this app here, take a look here on our phone, and hopefully everything will work just fine and we can authenticate the same way as before, just that we're now talking to our server. It tells us you're not authorized. Of course, that's the case. We want to sign up here with a new account. We want to type something like test account, YouTube, whatever. Typing a password, test account, password. And if we now click sign up, yes, It works. We are actually authenticated. And we are now really talking to our remote server that we deployed and not only to our local server anymore. And one thing we could also check is if Mongo Atlas is actually properly set up, which we can do here in Google Chrome. So if we go to Mongo Atlas, we go to our database, click on our cluster to just see the collections and see if the account was created successfully. Click on collections. Now it retrieves that, and scrolling down a little bit, here you can see here's our test account YouTube with our password and our salt. So that is working perfectly fine. So that was a super long video, I know, but this is quite an important topic to actually be able to use a custom authentication system, and even better if you learn how to implement your very own system and not only use it in an Android app. So in this video, you've learned both. You've learned how to deploy that to your very own server, so you're totally not dependent on anything like Firebase anymore, which I think is a very good thing. Thanks again to Hostinger for sponsoring this video. And if you actually want me to make more of these backend type tutorials in combination with Android, of course, then please let me know that in the comments, because if you don't tell me, I don't know. So other than that, I think it's time to wish you a brilliant rest of the week, and I'll see you back in the next video, which will be a little bit shorter again. Have an amazing day. Bye bye.